What's up, everybody? So we are getting into 5.5 today, finding slope. But before we do, I'm going to have you guys try a warm-up from our last lesson where we were finding the x and y intercepts of a graph. Okay, so just a little reminder on finding the x and y intercept. The big idea here is you need to be plugging in 0 for the other variable. When you go to find your x-intercept, you'll plug in 0 for y. When you go to find your y-intercept, you'll plug in 0 for x, and then after that, you can graph it. So I'm going to scroll this up a little bit. All right. So yeah, go ahead and find your two intercepts. After you do, go ahead and get them onto your graph and get the line there. Okay, try it out. All right, so let's start by finding the x-intercept again. That means we're plugging in 0 for y. So I'm going to rewrite this equation, negative 3x plus 9, but instead of y, I'm plugging in 0 equals negative 18. Okay, and then, pretty easy math from here. 9 times 0 disappears, so I have a negative 3x equals negative 18. Divide both sides by 3, and it looks like x is going to equal 6. Okay, and remember, go one more step and actually get the coordinate. That means my x-intercept, I have a 6 for x, and I plugged in a 0 for y. Okay, so that right there is the coordinate of my x-intercept. Okay, so let's go ahead and get that on our graph. Okay, here's our graph. I just did an x and a y axis. We're going to 6 on the x, so I'm just going to go ahead and go 1, 2, 3, 4, 5, 6. Okay, and 0 on the y, of course. And there is our x-intercept. And again, remember what an intercept is it's literally this point where our line crosses the axis, intercepts the axis. Okay, let's do it for y. Okay, so on that, this means we're plugging in 0 for x. So I'm going to rewrite my equation. Instead of x, plugging in 0 plus 9y equals negative 18. Okay, that goes away. So I have a 9y equals negative 18. Divide both sides by 9. Looks like y equals negative 2. All right, be careful. It'd be tempting to be like, oh yeah, negative 2 is 0, right? No, we plugged in 0 for x, and we got negative 2 for y. Okay, so there's our y-intercept. And that means on our graph, 0 on the x, down to negative 2 on our y. There is my y-intercept. Okay, and that right there is enough to graph a line. We just really need 2 points on some of these. So go ahead and connect your dots, and y'all have it. Okay, just make sure it goes all the way across your graph. Put some arrows on both sides of the line. Okay, so today we're doing kind of the first step in graphing in what's using slope-intercept form. That's actually going to be the next lesson following today's. Today we're going to just focus on slope. Okay, finding slope and understanding what it does, and then using what's called the slope formula to find slope. Okay, so it's all about slope today. Tomorrow, or I guess not tomorrow, but our next lesson, we'll be getting into actually using slope-intercept form, which is what this entire chapter has been kind of leading to. Okay, so first thing, go ahead and get the title, copy this first slide, we'll look at it. Okay, so finding slope, the first thing to put on, or I guess to really point out, is this right here. Slope equals rise over run. Something I might recommend. This is an important thing. So put a little box around it in your notes just so you can catch your eye if you go to look at it during a test or whatever. Okay, so slope equals rise over run. When we have the slope of a line, first of all, we always want it to be a ratio, a fraction, because we need the top number to be considered the rise, the bottom number to be considered the run. What those words represent, they're just kind of a shorthand as to where we go. Okay, so say we had this line right here, and we were going, we had this point, and we had this point. I already have them in green. Okay, to find the slope of these, we would first figure out the rise. And what I mean by a rise is how far up or down do we need to go to get level with the other point. So if you want to on this, you can kind of show yourself, rise, it's the up or down. Okay, run is the shorthand for us. How far left or right do we need to use? Okay, or do we need to go? I don't know why I said use. Okay, so left or right is what run represents. So on this one, you could see we would rise up the certain amount of points, and then we would run to the right a certain amount of points, and that would give us the slope of our line. Okay, this is just a generic graph. We'll eventually have some actual numbers to deal with, but that's the idea. That is what slope is kind of all about. Okay, so with that, let's go ahead and find the slope of a graph that actually gives us some points here. So go ahead and take a second. copy this. You can just draw yourself a simple graph. You don't need all of the little crossing. Just get your x-axis, your y-axis, and put the points on, and we'll go from there. Okay. Okay, so find the slope of the line. They give us this graph, and then we'll refer back to this thing at the end because it's actually something I've already pointed out before, but it'll make more sense in the context after we find the slope. Okay, so let's go ahead and do it. One thing to know, and you'll see this a lot in the future, when it goes to using or writing out the word slope, there's actually a shorthand for slope in algebra or just math in general, and it's m. Okay, so we can actually use m. They use m for some reason. I really don't know why, but yeah, they use m for slope. Okay, so let's just go ahead and start using it. So I'm going to say that our slope, and by the way, in your notes, it wouldn't be a bad idea just to kind of remind yourself. Okay, m, that means slope. Okay, so m equals what? It's the rise over run. Okay, rise over run. Okay, so when you guys go to find slope, here's my advice. I would always start on the leftmost point and make your way to the rightmost point. But just so you know, you could do either or, and I'm actually going to show you why it works either way. But my advice, just start on the leftmost point. Okay, so from this point, we're wondering, what is the rise, quote unquote? How far up or down do we need to go to get level with the other point? Well, you guys can see we need to go up 1, 2, 3, 4 units. Okay, so our rise is 4. Okay, the run is how far left and right do we need to go? Well, it looks like we're going right 1, 2, 3, 4, 5, 6 units. Okay, and by the way, the rules still work. If we're going up, we're going in the positive direction. If we went down, we'd be going in the negative direction. When we go right, we're going positive. When we go left, we go negative. So it just so happens that these are both positive numbers. You know, up 4, to the right 1, 2, 3, 4, 5, 6 it was, right? Okay, so there is the slope of this line. Here's the first point I want to make. This reduces, right? We can reduce this staying down. We can say that our slope equals 2 over 3. Okay, why does that work? Well, let's take a look. What if we went up 2 units and then ran to the right 3 units? We would still fall on our graph. That would still be considered the slope of our graph. Okay, so we will normally reduce our slopes, but just know whether you reduce it or not, you're still getting a point that lands on the line, and that's really what it's all about. Okay, so that's our slope. That's what they're asking for. Let me point out a couple more things. Say instead of starting at this point, say we started at this point. Okay, and we went to find the slope. Okay, well, remember, our slope is rise over run. If we started at this point, we would quote unquote rise down 1, 2, 3, 4 units. Okay, so our slope would be, or sorry, our rise would be a -4 because we went down. And then we would run to the left 1, 2, 3, 4, 5, 6 units. To the left is going in the negative direction. And we would get a slope with a double negative, which you guys know turns into a positive 4 over 6. Okay, so it doesn't matter which point you start at, but just I would recommend just using one way always so you don't get mixed up. I go left to right always. Okay, and here's part of the reason why I go left to right. This last thing, the line rises from left to right. You guys notice from the left, it's going, up from left to right. Okay, that will always happen when you have a positive slope. Okay, this is a positive, number, 2 over 3 or 4 over 6. That is positive. We should expect this slope to be going up from left to right. Okay, and this is a good thing because say this was going down from left to right and we got a positive number, we should automatically go, wait, something went wrong. This is going down. This should be a negative slope. I got a positive number. What happened? Okay, so you can catch some mistakes. Okay, let's keep on. Okay, so another one here. Go ahead and draw yourself another graph. We're going to find the slope, same directions. You probably don't need those again. Go ahead and get this and we will try it out. What am I doing? Okay, so yeah, again, let's use the shorthand M for slope. Okay, and let's figure out the rise of this. Again, I'm going to start on the most leftmost point. So I'm going to start on this one. And I notice that my rise is a -1, 2, 3, 4, 5, 6, and going down 6. So my rise, -6. Yeah, I'm using a bunch of different colors. I'll just try to keep it black here. Okay, from there, my run, I'm going to the right, so in the positive direction, 1, 2, 3 units. So my rise is 3. Okay, again, this is a number that reduces, so let's go ahead and do it. We know that 3 goes into both of these, so we're going to get a 2 over 1. Okay. One thing you might be wondering, why don't I just write this as -2, right? -6 divided by 3 is -2. Well, the reason why is because we always want our slope to be a fraction because, again, we want a rise over a run. All right, and I just want to point out one more time, what if I were to use this slope of -2 over 1? Well, that means I would go down 2 to the right 1, and I would still land right on top of my graph. Okay, last thing to notice, this is a line going down from left to right. We should have assumed that this was going to be a negative slope, a negative number, and that's exactly what we got. If we didn't get a negative number, then we would be able to find our mistake there. Okay, so make sure you get this little note on your notes. Okay, so with that, I'm gonna have you guys try out one of these. Same thing, asking you to find the slope, and then I want you to tell me whether this thing is going to be a positive or a negative slope. Actually, I want you to answer that first. Okay, take a look at this graph. Is this thing gonna be a positive number or a negative number? What do you think? Okay, hopefully you're thinking negative, right? It's going down from left to right. We should expect a negative slope. Okay, so go ahead and find the slope of this line, and then we'll see if we actually get a negative number. Try it out. Okay, so slope equals rise over run. I'm going to start on the leftmost point. It looks like my rise, quote unquote, is us going down 1, 2 units. Okay, so I know that means that my rise is a -2. Okay, my run is a positive 1, 2, 3, 4 units. So +4. And there it is, but let's reduce it down to -1/2. There's my slope. Okay, and yeah, it's a negative number, a negative slope. We expected it. Okay, real quick, I just want to do it again. What if I started at this point and went to the other one? Well, my rise would be a +2, right? And my run would be a -1, 2, 3, 4 because we're moving in the left direction. This would still reduce down to a -1 over 2. That negative, by the way, I put it down here, but it kind of applies to the whole graph. Normally, like this right here, that negative applies to this. This is a -1 over 2. Okay, and it can actually apply to either one of these numbers if we needed to actually do that. Okay, okay, let's keep moving. Last thing here is the slope formula. Okay, basically this formula, what it does is it helps us find the slope if we're not given a graph. If we're not able to actually count, oh, this is the rise and this is the run, this formula helps us. It looks scary because of the 1s and 2s, but it's actually really simple. Something you might want to do, put a box around this thing because it's another thing that's pretty important. Okay, so yeah, we're just plugging in, we're going to be given 2 points. We're going to plug in our y values on the top, x values on the bottom, do a little math, we'll have our slope. It's that simple. Okay, let's try it. Okay, so find the slope of this line that passes through these 2 points. Go ahead and copy this example and we will do it together. Okay, so first things first, notice there's a y1, a y2, x1, x2. All that is just saying first y, first x, second y, second x. Okay, so when we go to label these points, remember this is always x comma y. So this is going to be my first x, which we call x1. And this is going to be my first y, which we call y1. Okay, really it's y, it's x sub 1, y sub 1, but I just say x1, y1. Okay, on these, that's my second x, x2, and that's my second y. Okay, so labeling the points, I always recommend doing that. It's really easy to mess up if you don't. Okay, so let's go ahead and let's write it out. Okay, let's write out our formula again, just so we can have it in front of us. Just a little reminder, y2 minus y1 goes on the top, x2 minus x1 goes on the bottom. Okay, just for the sake of taking good notes, not a bad idea to write out the formula. Okay, let's plug in our numbers. So y2, looking over here, we labeled them, so we're not going to mess up. It's a -2. And I'm subtracting a y1, which is 2. Down here, x2 is a 5. And I'm subtracting x1, which is a 5. Okay, so let's see what's happening here. This is giving me a -4 on top, so I'm getting -4. Okay, and on the bottom, I'm getting a 0. Right? So this is my slope. Here's the thing. In math, we cannot divide by 0. Okay, we can't do it. It's not something that works. So this is actually kind of a special case problem as well. If we ever get 0 as our denominator, this is actually a slope that's called undefined. Okay, and what that means is there's, I don't want to say there's, it means that there's no slope, but technically undefined is a completely vertical line. Okay, and you can think of it like a if you're walking down the street. Okay, if something is a slope and you're walking down the street or you're walking up the street, yeah, it has a slope, but you wouldn't consider this to be a slope. This is a wall. You're not walking on this thing. You know what I mean? So undefined. If you want to draw a little arrow up and down, that's what it looks like if we were to graph it. Okay. All right. So I'm gonna have you guys try one of these on your own. Go ahead and plug these into the slope formula. See what you get. Okay, so just for the sake of it, let's try out the slope formula again. Y2 minus y1, x2 minus x1. Okay, before I get ahead of myself, let's label these points. Here's my first x, first y, second x, second y. Okay, so plug them in. Let's see what happens. Okay, so x2 minus x1, just going back here. Okay, x2 is 4. And I'm subtracting y2 is a 4, and I'm subtracting y1, which is a 4. On the bottom, x2 is a negative 3, and I'm subtracting a 0. All right, so here's what we get. And if we do our math here, 4 minus 4, we're getting 0 divided by negative 3. Okay, here's a question. Is this also an undefined slope? Okay, no, it's not. We're not dividing by 0 like we did on the last one. The last one, 0 was in the denominator. This one, it's in the numerator. That's okay. We can divide numbers into 0. 0 divided by anything is just 0. Okay, so we can actually go one more step here, and let's show that the slope of this line is actually just 0. Okay, and sometimes you'll see on problems, instead of writing slope equals 0, they'll write out the word 0. Okay, just to kind of make it kind of like undefined. It has a word. This one has a word. But if you guys know, one thing to know, a slope of 0 is a completely flat line. All right. Again, if you were walking down the street and the pavement was completely flat, you would not be thinking, oh, this thing has a slope to it. It's not sloping up, it's sloping down. It has 0 slope. Okay, so that's just a good way to think about it. If you ever mix up the whole, like, which one's undefined, which one's defined, it's all about, the line, if it's horizontal or vertical. Okay, so that kind of is what gets into this here. You don't need to write this because I feel like we already did these examples. This is asking us to find the slope. Actually, I take it back. Let's write these real quick, and then we will we'll do these together. So we'll call this an example. Draw this graph real quick. It'll be a good thing to kind of show yourself. Okay, so slope of the line, we have these two things. It says find the slope. We could plug these numbers into the slope formula, and I know what would happen just by looking at this. This is a completely flat line. I know my slope is going to equal 0. Okay, so I'm just going to go ahead and do it. Okay, by the way, the reason why this works, let's use our old-fashioned way. Let's use rise over run. If we were to look at this point, what is our rise? How far up and down are we going on this graph? We're not going up or down. So our rise is a 0. Okay, what's my run? Well, we're going to the right 1, 2, 3, 4, 5, 6. Okay, but really it doesn't matter because 0 divided by anything is going to give me 0. So on this one, I still get a slope of 0, or let's just write the word 0. Okay, so just always something to remember, and this is worth writing out. A line is horizontal, slope is 0. Okay, all right, I think this is the last one here. Yeah, okay, so go ahead, get this last graph of this vertical line, and we'll kind of show why it's undefined. Okay, so finding the slope of this, let's use the old-fashioned rise over run. I'm going to start with this top one. Okay, what is my rise? Okay, well, it looks like I'm going down 1, 2, 3, 4, so it looks like my rise is a negative 4. Okay, what is my run? How far left and right do I need to go to get level with this point? I don't need to. So my run is a 0. Okay, and we ended up with a ratio with a 0 in the denominator, which is not possible in math. So the slope on this thing is undefined. Okay, so just remember vertical line, if you ever see it on a graph, boom, undefined. Okay, really quick problems. All right, guys, so that's slope. We will be using this on the next lesson when we get into slope intercept form. Okay, see ya.